Okay, number games. Number games are fun when you can figure out the answer, and when you can't, they can be super frustrating. These are questions that you might not have run into in your standard everyday 6th and 7th grade math life. So you should get used to them because they are on the test, and you know, like I said, if you get them, they're fun. Okay, let's get to work. Question 1. What is the median of all prime numbers from 0 to 20? Okay, here are all the prime numbers from 0 to 20. Remember, a prime number is only divisible by 1 and itself. So 9 is not a prime number because it's divisible by 3, including 1 and itself. 1 is also not a prime number. Everyone knows that eventually in life, so you should know that now. 1 is not a prime number. Just know it. It's okay. It's not that hard to learn, just learn it. All right, so what's the median? Don't get the average, don't get the mean, because it asks for the median. So you have 4 here, you have 4 here. You know when you have an even number, it's the average, the median is the average of the middle two numbers. So what's the middle of that? The middle of that is 9. We're good to go. Question 2. There are 8 carriages on a Ferris wheel, each labeled in order with the first 8 letters of the alphabet. Carriage A is on top, and then the wheel spins 33 times. Which carriage is now on bottom? Okay, so you have 8 carriages, so it'll look like this, right? And you have A on top. And you're like, oh my gosh, well, which way does B go? Because it doesn't tell me that, and that's tricky. And you only have 95 seconds to answer this question, and some people might spend 95 seconds just worrying about which way, where to put the B. So, you know, to make that clear, should it be like A, B, C, D, E, F, G, H, or should it be A, B, C, D, E, F, G, H? You're like, I don't know, but let's see if it matters. All right, so the first wheel spins 33 times, and you're like, I don't know which way it spins, but it doesn't really matter, right? And then it stops. A is still going to be on top, right? Because it spins a whole time. A is still on top. Which carriage is now on bottom? C, it doesn't matter. The answer is going to be E. We're good. Okay, question 3. Which of the following numbers is evenly divisible by 3, 4, and 5? And you're like, oh my goodness, am I going to really have to do long division out for each one of these? Am I really going to have to do 50,115 divisible by 3 and see if it works? And if you decide to do it that way, you're not going to get it done in 95 seconds. And I have to just say that these kind of questions, they have been on the SHSAT before, and they're kind of bizarre because they really test whether or not someone has taught you a bizarre kind of rule for the number 3. And that rule is this, so when you see it, you can be like, ha ha ha, I know it, I'm gonna get it right. Other people are not gonna know it. The person to my left, the person to my right, they might get it wrong, but I'm gonna get it right. So a number is divisible by 3 evenly if all the digits in that number add up to a number that is divisible by 3. So if you have 50,115 and you have 5 plus 0 plus 1 plus 1 plus 5, and you add up all the digits, right, and you get 12, right? Because 12 is evenly divisible by 3, you know that this number is evenly divisible by 3. And you're like, okay, that one's evenly divisible by 3. I like that. How about this number here? 5 plus 0 plus 1 plus 4 plus 0. Well, that equals 10. That's not evenly divisible by 3 because 10 is not evenly divisible by 3. Here we have 5 plus 0 plus 1 plus 5 plus 0. That equals 11, not evenly divisible by 3. 12 is evenly divisible by 3, so this number is evenly divisible by 3. These are voted off the island. Here we go. 50,000, 5 plus 0 plus 1 plus 6 plus 0. Again, we have a 12er, so we're good to go. Okay. Now, so 3 is taken care of. Now we go to 5. 5, obviously the end number has to be a 5 or 0. If it is a 5 or 0, it's evenly divisible by 5, so we don't even really have to do much work there. We know A and D are evenly divisible by 5. What about 4? Well, because 4 goes into 100 evenly, all you have to know for a number to be divisible by 4 is if the last 2 digits are evenly divisible by 4. If 15, we're doing this one now. If 15 is evenly divisible by 4, then this number will be evenly divisible by 4. Guess what? 15 is not evenly divisible by 4. We know this one is no good. That leaves us with this, but we can also confirm that by saying 60 is evenly divisible by 4, right? Because it's 15, because you know 1, 4, 2, 0, 5, 2, 0, 0. Okay, so that's evenly divisible by 4. So we know that this entire number has to be evenly divisible by 4. And there's our answer. Question 4. I love question 4. When I thought this question up, I gave myself a high five because I was like, what a good question. Which of the following numbers is prime? And you're like, oh my gosh, how do I do this? How can I possibly do this? But this is a question that could be on the test. And if it is a question on the test, it can be done in 95 seconds. So what should you do? Well, I think a good place to start would be saying, well, let's see which one of these are divisible by, 3s, 5s, etc. Because if it's divisible by 3 or divisible by 5, it's not going to be prime. And that's a good place to start because these questions have to be able to be done in 95 seconds. So let's look at this number. Remember the rule we just talked about? Adding up the digits. 1 plus 0 plus 1 plus 1 equals 3. 3 is evenly divisible by 3. That means that number is evenly divisible by 3. You're gone. How about this number? 1 plus 0 plus 1 plus 3. That equals 5. Okay, so that's not evenly divisible by 3, not evenly divisible by 5. So you're kind of still in the running. Let's jump down here. 1 plus 0 plus 1 plus 5 equals 7. All right, not divisible by 3. Oh, but wait a second here, guys. Boom, boom. That's a 5. That means it's obviously divisible by 5 evenly, so you're voted out. Goodbye. And we have 1 plus 0 plus 1 plus 7 equals 9. Ha! You are also evenly divisible by 3. Answer's got to be B. Okay, question 5 is a good question too because it's tough and you can stare and you can stare and you can stare and you just might not be able to get it. But if you do a lot of these and you hear the explanations and you work through them, you're going to get better at them. And when you see them on the day of the test, you're going to have a better shot of getting them. And if they just come naturally to you, that's awesome. Run with that strength. Below are the first 10 numbers in a pattern. What is the 15th number in the pattern? And initially you might be like, okay, well, what are we doing here? We have plus 2, plus 2, plus 2, plus 6, plus 2, plus 14, plus, what is that? 2, plus 30, plus 2, and you're like, oh, I don't understand what's going on. Sometimes it's plus 2, sometimes it's plus another thing, and you just got to look at it, and it might come to you, it might not. It's kind of when they ask these pattern questions, sometimes it's more, not as something you can study for or a rule you can learn, as it's just a familiarity you have to get. It's more of an art, and the more time you spend with it, the better you're going to get with it. But you shouldn't be nervous or sad or anxious that you don't get it right away. Just spend some more time with it. If it's not your thing, you can still get a bunch of questions wrong and still get into a good school. So here we go. Plus 2, plus 2, plus 2, plus 6. Well, there's a 6 there. Plus 2, plus, there's a 14 there. There's a 30 there. Oh, I get it. Okay. So it is plus 2 times 2. Plus 2 times 2. Plus 2 times 2. Plus 2 times 2. Plus 2. That means this is going to be times 2 to go to there. Plus 2 to go to there. Times 2 to go to there. And how many spaces do we need? We have 10. So we want to go 11, 12, 13. Times 2 plus 2 times 2 plus 2, and then we go times 2. All right, so that'll be our 15th spot. So we have times 2 to get us to 124, plus 2 to get us to 126, times 2 to get us to, what is that going to be, 252. Then we're going to plus 2 to get to 254. Then that's going to be 508. We're good. Question 6. X and Y are both whole numbers. Which of the following must be true? 1. If x is even, then the product of x minus 1 and x must be even. If x is even, then the sum of x minus 1 and x must be even. If x is even, then the sum of x and 2y must be even. And then you have your 1, 1, 2, 1 and 3 only, 1, 2 and 3. You're like, oh, what do I do? All right. Well, this is just a simple problem-solving technique. We've talked about it at school. Your middle school has talked about it a lot. If you have these, x and y's, we'll just plug in simple numbers for them and see if you can get something that works. Okay, so if x is even, so let's just say x equals 4. Then the product of x minus y and x must be even. Well, if x minus y is odd, an odd number, let's say that's 3, 4 times 3, because product of multiplication is 12. Okay, that's even. And if y minus 1 is even, let's say it is 6, 4 times 6 will also be an even number. That'll be 24. So 1, you're good. How about 2? If x is even, then the sum of x minus 1 and x must be even. So again, let's do 4 and 3. Well, that's odd right away. Okay, let's try again. If x is even, then the sum of x and 2y must be even. All right, so let's say x equals 4 and say y equals an odd number and y equals an even number. So let's do the sum of 4 plus 2y is 4 plus 6. That's an even number 10. And 4 plus 12, that's 2y, 6 times 2 is 12. That is also an even number. Kind of neat, huh? If you take an odd number and you multiply it by 2, you get an even number. If you add an even number and an even number, it's got to be even. And if you multiply a even number by any number, it's got to be even. So 1 and 3. Now some of you might just have said, oh, I know the rules. An even number multiplied by any number is even. And you could kind of like do a two-stepper for number 3. Either way, we're good. Okay, question 7. What is the units digit of 7 to the 7th plus 77 to the 7th? And you're probably looking at this being like, I have no idea how to do this. But it's just a pattern question. It's just a pattern question. If you have 7 to the 1, then 7 to the 2, then 7 to the 3, then 7 to the 4, what do we get? 7 to the 1 is obviously 7. 7 to the 2nd is 49, so the units digit will be 9. What is the units digit going to be for 7 to the 3rd? Well, you should know it's 343 right off the bat, but you know it's going to be 7 times 9, right, which is 63. So whatever these other two numbers are, another 3 or another 4, whatever you have in the tens, hundreds, or thousands, or 10,000s, or whatever, you know your units digit is going to be a 3, right? Because you have 7 times 7 times 7. 7 times 7 is 49, 9 in the one's units digit, and then you have that times 7, which gets you 63, so 3 is going to be in the units digit. Then if you have this again, 7 to the 4th, we're going to have a big bunch of numbers, but the last digit is going to be 1. Why? Because 3 times 7 is 21, and you know that it's 7 to the 3rd times 7 is 7 to the 4th, right? So you're going to have 3 times 7, that's going to give you a 1 in the ones digit. Okay, so 7 to the 5th, 7 to the 6th, 7 to the 7th, and 7 to the 8th. All right, what do we have again? Well, we're going to have 1 times, is a big number ending in 1 times 7, it's going to end in 7. This is going to end in 9, this is going to end in 3, this is going to end in 1. So it's going to go on forever in that pattern. You're going to have 7931, 7931. Okay, so what is 7 to the 7th? You don't have to do all the math out. You know it's going to end in a 3. So the units digit of 7 to the 7th is going to be 3. What's the unit digit of 77 to the 7th? Well, it's the same deal, right? Because it still has 7 in the ones digit. So no matter what you have before it, it's still going to follow the same pattern. And you're going to end in a big long number, ends in 3. A big long number that ends in 3 plus a big long number that ends in 3 is going to add into a bigger long number that ends in 6. Well, we're good. All right, question 8 is kind of a jerky question. I probably shouldn't have included it, but I read it somewhere and I got it wrong when I was doing an SAT question. So I was like, oh, got to include it, right? And here we go. How many numbers between 0 and 100 are prime and evenly divisible by 17? And you're immediately like, prime numbers are not divisible by anything. So the answer has to be 0, but the answer is 1 because 17 is a prime number, but it is evenly divisible by 17. So it's kind of a trick question, but the answer is 1. So we're good. We return to these pattern questions in question 9, and they're tricky. You just got to hear the music. You just got to look at it and get it, and the more time you spend with it, the easier it's going to be. So maybe your first step will be, all right, plus 5, plus 5, plus 5, plus 5. No, then we do plus 10. Now we do plus 15. Now we do plus 25. Now we do plus, what was that, 40, and now we do plus 65, and you're like, I don't see any pattern in that. And you just look and you look and you look and you're like, all right, that's all by 5s, so what are we going to do? And then you look and you look at you feel the time pressure, and yeah, they're tricky. if you look at it long enough, you might start to see that 0 plus 5 is 5, and then 5 plus 5 is 10, and then 5 plus 10 is 15, and 25 is 10 plus 15, and so on and so forth. So what the next number is the prior two numbers added together, which is kind of a common theme in number pattern questions, but it's tricky. It's tricky. I have sympathy for you. If you're not able to get it, doesn't mean you're not going to pass the test. It's just a tricky question, and you don't want to spend more than 95 seconds on it. You either see it or you don't, and you can always come back to it, but you don't want to have this question waste all your time or ruin all your stamina. You just got to get through it. But if you see it, that 105 plus 170 is going to be 275. And then those two numbers added together, right? Because you have 10, you're just 11, 12. You're looking for the 12th spot. Is going to be 445? Yeah. We're good. And finally, question 10, how many triangles in the figure below include point A? And you should really think about this strategically. You can't just look and just kind of guess, here's a triangle there, here's a triangle there. You should try to have a mindset of I'm going to do this in a strategic, orderly way. And here's how I would do it. I would say, okay, we have one triangle here, one triangle here, one triangle here, that's 3. And then we have a double triangle here, 4, a double triangle here, that's 5, and a triple triangle here. They're all triangles, and there's 6. And then you can say, well, for every endpoint, you know, we're going to have those same 6 triangles, right? Because the triangles can end here, the triangles can end here, the triangles could end here. But for each of those endpoints, you're going to have 6 triangles. So it's going to be 6 times 3, and that's 18. And we're good.